Hi, how we doing, everybody? Doing good? How's the lectures gone? Okay, good. Exams going good? Homework's all going good? Everything's going good in the class? Yes, no? Are we understanding what state space equations are? Difference equations? You guys understand what's going on? How was the assignment last time? Actually, John, how did they do on assignment 2? Oh, you haven't checked it out? No, it's okay. Anyways, huh? Wasn't that bad? But did you see that the answers were all in the book, right?
It was all on the book, but for the direct block one, direct block two, yeah, it was all on the book.
Yeah, so I'll show you guys something. Don't copy it, because if you don't copy it smart, I'll tell you what's going on. So let me show you. So the answers are in the book, but don't copy it like blank by blank. It's not wrong, but let me show you. So if I were to do a block diagram, is everyone a master at this? Right? I'm going to do this plus this. This is the way I draw my first order block diagram, or not first order, direct form 1 block diagram. Right? So if I wanted to do a direct form 1, I'm preparing a direct form 1. I have some node C of n. Why do I have that? Because I'm adding all the feed forward paths, right? Feed forward blocks, correct? So if I were to do the following, let's just say this right here, B0, right? That's a gain at the first point, right? And this is a delay, correct? We're all masters of this, right? Plus, and then I can just do dot, dot, dot. No dots. Screw dots. B2, correct? Is that good with everybody? Everyone understand? This is very simple stuff, right? Well, let's just say you were given a problem where y of n is equal to, let's just say, b1 x of n minus 1, right? Plus b2 x of n minus 2, correct? So what does this mean about our inputs? We have 2 delayed inputs, correct? Does that make sense? How do we get that delay through this delay block, right? What's b0? There's no b0 in here, right? It's 0, right? So let's just say, I'm going to do this. This is what you see. This is the answer that you see in the book, the general answer, right? But if you do this, you're not wrong. But understand what's going on. B of 0 is equal to 0. It doesn't exist. So hear me out. The answers are all in the textbook. And you can technically copy this for every answer in this course, in this whole course. And do this, like do B0 is equal to 0, B1 is equal to, I don't know, 0, dot, 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 whatever you want. And just siphon out whatever you want to, I don't know, A, need equal B. So you can start punching in what you truly want and what you need for your assignments. Does that make sense? So technically, you can copy and paste that whole code that Dr. Seaver gives you, but do you understand what's going on? So you can totally do this, but it's going to be painful for y'all. But all you do, this is like literally like cheat 101. I'm teaching you guys how to do it. So this is how you it's not technically wrong. You just understand that we don't have this B0 term. So when you're drawing your block diagram, this is technically correct, but there's another way of writing it. If I were to do it like this, x of n, right? You can just do this, d, another d, right? B1, B2, sum, and that's C of n. Does that make sense? So there's no term in here. It doesn't exist. It's just an open. Does that make sense on how to do this next assignment? Don't believe me? Let's see. Computer assignment. Oh, look at that. Where's the x input? X of 1. It's just, there's nothing. It's just this. Does that make sense? So what am I gonna see in the homework? See, it's missing. All right. But if you do the copy pasting from Dr. Stubert's textbook, don't forget that, because if you start putting this as like 1 or something like that, it's not going to work. So that's why if you want to be smart about it, understand what terms are given on the computer assignment as such, right? We have a delayed input, right? And look at this. We have a delayed output, an output, right? What's A0? Just by looking at just this term. 1, right? Does that make sense? When you guys look at the textbook, the answers in the textbook, I'm reiterating this. A0 is just 1. A1 is, well, I'll show you. We'll go over this. Next page.
So basically, the 2r times cosine omega naught is our A or B.
I'll show you how to set it up, but you need to understand what's going on. So let me show you this. Page 2, and then I'm just gonna look at this screen. I'm gonna copy this. Y of n minus 2r cosine omega naught. Because someone's screaming at me saying, David, I don't know this class. This class is hard. I'm gonna fail. Like, should I drop this class? Like, coding is hard. Yeah, coding is hard. I don't blame you guys, but I'm gonna try and show you that it's not. It's very helpful. It's a tool. Sine x of n minus 1. Okay. Boom. Is that good? Yeah, it could be better. So these are just numbers, okay? 2r cosine omega naught, right? What's omega naught? Or omega 0? It's just a fundamental frequency, right? It's a frequency you pick, right? Or resonance or whatever frequency of the system, right? 1 kilohertz, correct? So that's a constant, right? You go into your 221 labs or 320 labs and you pick a frequency, one frequency, right? 1 kHz, right? That's a constant, right? What's R? It's just another parameter, right? Another dance parameter. Is that good with everybody? So what can we say about this whole term? It's just a constant. Does that make sense? So if I were to rewrite it as this, is anyone bothered by that? No? Everyone's understanding what's going on? So now, what's this r squared? That's also another constant. It's just a number, right? But should I do a minus or should I do a plus? How are you taught in class? I'm going to do n from I is equal to 0 of a I y n minus I, yeah. Is that good? Right? See this? I'm just picking random things. B, J, X of n minus J. Remember this equation? Good old outputs are equal to inputs. Is that right? Remember? Right? Simple like KCL or whatever, right? We're just kind of, yeah, you're not wrong there. But what happened when we popped out the first term, right? We can rewrite this as, watch this. Are you guys paying attention? I is equal to 1, all right? I siphoned out the first point, correct? A of I, y of n minus I plus, correct? I want the 0th term, right? I just pulled it out. A0 y of n, right? And then all I did was just make y of n is equal to n I equals 1, a I y of n minus I. Wait, hold up. Sorry. Put a big minus. Minus. See that? There's a minus. All right? Is everyone following? Did I lose anybody? No? We're all understanding why the minus is here? And then there's a plus. Plus. MJ is equal to 0 because I want that the first term, right? The first not delayed term, just the current term. B of J x of n minus j, right? Does this make sense? The B's are positive. The A, well, it's a number, but there's a minus sign. Is that understood? Is that understood that if I do this minus A of 2, correct? Y of, oh, someone didn't catch me here. Is that good? Is that understood with everybody? And then R sine of omega naught. What's omega naught? It's just the frequency and operating frequency, right? Fundamental or whatever we're working on, 1 kilohertz. So that's just a constant. We just chose that number. Understood? So we can call this B of 1 because it's delayed by 1, right? X of n minus 1. You can punch this in the MATLAB and get going home. Is that good with everybody? Does everyone understand how to do this assignment? How to do the block diagram? So like when we're doing these terms over here, these are positive, correct? And then what I want to do with the feedback path, correct? Y of n is going to see a negative A, right? Right? So I'm going to do the following. Let's see. I'm going to delay the signal, correct? Delay. And we want to see a negative A, A1, right? Plus. Does Y of n see that negative A? Correct? Is that good? So that's what we're putting in this block diagram, a negative A1, all right? It's not tucked in there, it's just floating right next to it. Is that understood? And then if I wanted to do the minus A2, I would just keep going down. Can we do block diagrams now? All good? And then what's this right here? If I were to draw like an imaginary line. It's A0 equal to 1. Just a wire. Is that understood? We're going to get A's on the next exam coming up this Monday? No? Anyways, so let's see. What else did you guys talk about in convolution? Is that what you guys are going over right now? Yeah. What do you guys learn? The properties of what a linear time invariant system is? Camera see me? Yeah, the camera sees me. Don't believe me? Here's the camera. Now the YouTubers can see that one too. Convolution. So have you guys performed any operations on how to like calculate that mathematically? You saw how painful it was? You have to do like some weird circ shift and you got to do the hands and the fingers and the train tracks. And you got 2 signals, you flip one and then you start adding them like this. Did you do that example? No?
No, it was like a paper. I think our example was on paper, like 2.
Yeah, it's literally 2 pieces of paper, and all you're doing is if my signal is just this piece of paper, right? If the signal is just a piece of paper, right? And then I have another exact same signal, right? All I do is I flip the signal and then I just add the area as they approach. You'll see a triangle. Does that make sense? When you have 2 square waves or 2 pulses that correlate together, you get a pulse or a triangle. That makes sense with everybody? Let's see. Page 2, page 3. Let's go over your assignment. Direct form 1 block diagram. Everyone can do that right now. We can get an A on that. You can get a few points just for drawing that block diagram. Did you notice that he gave you points for a few of these? Just drawing it, knowing how to do it, right? These are all basics, fundamentals. Direct form 2, transforms direct form 2. Did everyone know how to do a state space equation? Do you guys do the Shalom's outline book and look at the end of the textbook and see all the good old state space equations? Does anyone understand what a matrix form is? Yeah, so there's a way to do it in MATLAB. I'll show you. You could have done it the what do you call it? The brute force way, which is just not using matrices, but you can do it another way where, let me show you. Oh, that's Discord. This right here is what I want. There you go. Where's my sheet of paper? So in MATLAB, there's another way you can do this, where you can have these vectors. Like here's, what was it? You have current states, right? Current states is equal to not current states. Future, because I want to calculate the future, correct? Q plus, and then Q now. Current state plus B, input. Does that make sense to everybody? And then the output Y is equal to, A, B, C, am I doing this correctly? C of Q plus D of X, is that correct? Did I get that right? So in MATLAB, you could have honestly done this, where if you guys did it on your assignments, Q of N plus 1, you're going to figure out how to arrange that array, right? Is equal to A0, Q, or whatever that is, Q of 1, and then plus whatever B0. I'm just creating some numbers, X of N. Does that make sense? You could have done like a brute force way like this. Q of Q1, Q2, right? I'm just creating some numbers. Q something, I don't know, 1, Q2. Actually, yeah, I'll show you this. A1, Q of 2, Q1 of N plus I don't know, 1, 2, Q of. You see this big fat equation right here, right? And then I'm just gonna put some random B0x, right, plus B1 of x, correct? What was the matrix that you guys saw from A? What did you notice? The shape. It was a square, correct? See this term right here? See this term right here? I'm just making a random problem. If you just siphon this out so that A is equal to, I don't know, A0, A1, A1, A2. I'm just creating some random matrix, right? And this right here is technically your Q, correct? It's a 2 row by 1 column, correct? For your MATLAB codes. Is that good? And then this right here is a 2 by, and then this right here is a 2 by 2. We want a 2 by 1. Let's see. A2. Let me see. How do I do this? Q1, Q2. Is that correct? If I have a 2 by 2 times a 2 by 1, I get a 2 by 1 result. Is that good? Right? Plus B of 0, B of 1, X of N. Is that good with everybody? Instead of doing this brute force way, you can. This is fine. It'll work. Did you guys do this in your codes? Like this brute force? I think I did that in previous years. But after rereading this assignment, that's why I'm always learning too. You can brute force this way. Is that cool? Because Matrix Laboratories, MATLAB, it's a matrix. So you can just do a big Q, and maybe we'll try this. I'll show you what I mean. So let's see. What should we do? Should we do problem 1? Or which one should I do? I want to do a state space. Because you can only do state spaces for systems with memory. All right, there's Q1, Q2. So which one should we do? Transposed or direct form 2? You choose your difficulty. Which one's easier? Which one's harder? Transposed? Why'd you guys pick it? Because there's more words. More words means it's harder. I'll tell you this, it's actually easier. What's up? Yeah, sure, let's do it. So let me see. Based on what I remember, Because the reason why I said transforms direct form 1 is easy is I'm going to do some funny signs. The input looks like this. You're just doing some weird spider web like this, and the output does this. It's really cool the way you do direct form 2. It's you got B1 and A1, and they're all just like this. So that's why direct form 2, it looks like this. It literally looks like this. This is transforms direct form 2. Is that correct? Yeah. Where it's literally X. It's like this funny, like these are your fingers. And then all the delays are in the middle. And then the Y looks like this. That's why I said direct form 2 is easy. You just do the funny fingers going into your system because the water goes up. Does that make sense? But what happens if the water goes down? That's what we want to try to do. So let me see, this is page 4. How do I want to do this? So I want to replace I want to have the waterfall go down. So I'm going to install these memory blocks. I'm going to draw this from memory, but you tell me. X of n. And let's see, plus. Let's see, and have this going. Let me think. Because eventually it goes down the waterfall. It goes in here. B of 1 plus. No, I don't like that. Hold up. A of 1. Anytime anything goes backwards, we're feeding that back in. So that means this is actually minus A of 1. Is that understood with everybody? You guys checking me, right? See? You guys are doing good. All right? I heard that the averages were like 40s or something like that. Don't worry, that's typical. You guys are doing okay. If you're getting around the average, you're fine. So don't worry, don't lose hope, okay? You'll learn as you go, okay? So let me show you this. A minus A2, right? Is that good with everybody? Is that good? And then what I'm trying to do is B of 1, B of 0. I think that's how it works. Plus, yeah, Y of n. I'm just coming up with this as memory goes. So, and that's where I got the master's degree. So, anyways, you see the water flowing forward, right? The X, right, gets multiplied by B of 0, and that's seen by the output, correct? X delayed, right, goes through B1, correct? X to B2, right, delayed twice. We did the direct form too. Is that good with everybody? So, how do I start? What's the next step? Now that I wrote my whole thing, actually, let's look at the assignment. Actually, do I look at the assignment? You have one delay, two delay. Yeah, we're fine. Second order. So you see how you can just copy and paste this from the answer in the book, correct? But we want state spaces. So I'm just going to define a state. Q1 n plus 1, correct? But it gets delayed, correct? What happens? Q1 of n. Is that good with everybody? I'm going to create another state, right? Before this memory. Q2 of n plus 1, right? What happens when I delay it? You get the current state, Q2 of n. Is that good? Yeah. I'm going to lightning this. I like this. Let's write it bigger. Is anyone mad if I do this? Q1 n plus 1, right? That's our next state. We're trying to predict that, right? Our delay, right? Q1 of n. Is that understood? Now I do my branches, right? Q2 of n plus 1, right? And I want to delay that, correct? Q2 of n. And we're going down the hill, we're going down the waterfall, right? Then I want to delay, or I'm going to feed back with A2, correct? Then I need to add another one right here, another gain, A1, correct? What happens when two paths meet together? You add, is that good? And what happens when two paths meet together? Also add. Is everyone getting this? All good? So now we got to do our B of 1, right? And I'll leave that there. And no, let's just solve for everything. B is 0. We're going to go over this whole proof so that everyone can get an A in this class. All right, let's get our equations. We want to know our current states and we want our current inputs. So I want this and I want this. Okay, that's the objective of the game, right? But I have these currents or future outputs and, well, the output itself. Does that make sense? I want to solve in terms of Q, next state, Q of n plus 1, and y of n, right? Those are the two that I want to solve for, right? So what are some equations I can do? Well, if you see this right here, let's see, Q2 of n plus 1 is equal to Q1. That's a guaranteed answer right there, right? Everyone like a guaranteed answer? Is that good? And then, but what's Q1 of n plus 1 equal to? It's equal to our input, right? Our current input. Boom, gotcha. Easy. But it equals all these other things right here, right? Let's see. It's going to equal to minus A1, right? And is anyone bothered if I... What's A minus A1 multiplied by? This node, right? What's this node equal to in terms of current states? Q1, correct? Because I want the current state, right? Minus A2, right? What's our current state? Q2? All good? And look at that. Can we solve for the future using the current states and current inputs? We can consider that a job well done. You guys did it. You guys got an A. Is that good? And then better yet, look at that. Q2 is already solved. Because what's Q1 of n? Well, that's it. Is that easy? Who's ready to do the matrix? We want the matrix. Q, right? Is that good? What is that going to equal to? Q1 of n plus 1, right? Q2. Is that good? But now I want my, what do you call it? Let me see. My A, Q, or actually, yeah, not Q. Do I want to do that? I'll just do big Q. Q of n, right? Plus B of x of n. What's A? Or actually, better yet, I'm going to do A right there, okay? Just going to put it on the side, right? What's Q of n? Or better yet, got to look at our answers, okay? How many Q future states do we have? We just have Q1 and Q2, right? So that means we're going to expect a 2 by 2 matrix, correct? So that means if I look at Q1, right? N plus 1, right? It's equal to a current state, right? It's got one current state and another current state, right? So if I do this, Q of 1 of n, right? Or big Q, or actually, no, it is little q, sorry. Q2 of n, right? Those are our two signals that we want to play with, right? We're going to absolutely use these signals. Is that good with everybody? Now we need to start turning these signals on. For Q1, right, we're using this term right here, right? Minus A1, right? So Q1 right here, Q1 of n plus 1, Q2 of n plus 1. So that means it's going to be the first point right here, minus A1. Is that good? And then I want this minus A2. So that means, let's see, if I want to do this, it would go right here, minus A2. Is that good with everybody? Now I want this state right here. What do I put right here? Q2 of n plus 1. It's just this Q1, right? It's just 1. So where do I put that? Well, I want this one. Because it's basically, do you guys see what I'm trying to do? It's like, it goes like this. This multiplied with this, plus this multiplied with this, right? And then this number right here multiplied, we want that, right? So we want to put a big fat 1 right there, right? Plus, do we want a Q2? No, right? Why? Because it's not on the equation, right? What's your A? There you go. Done, right? Now let's do our B of n plus x of n. Does our first equation have it? Yes, there's 1, right? So I want to put that on the top, right? Is that good? But our second one doesn't have 1, right? We did it. You punch this into MATLAB and you're done. Go home. Is that understood with everybody? So you already got the first 2 answers. Now you just got to punch in everything. Now let's see. What about our output? What's our output equal to? I'm going to write it right here. Y of n. What do we see? B0, right? Well, what's B0 being multiplied by? Q1 n plus 1, right? So I'm going to do B0 Q1 n plus 1, right? What's Q1 n plus 1 equal to? Is there an equation we can punch in? Oh, yes, there is. B0, right? I'm going to do this. Is anyone mad if I do this? X of n, right? Minus A1 Q1 of n, right? Minus A2 Q2 of n. Is that it? Is that it? All good? I'm going to simplify it on the next page. Is anyone mad if I try to do the following? You see how this B of 0 is in everything, right? And you see how there's A1 there and A2 there. How do I want to show you this? And I'll show you what I got. Y of n, right, is equal to minus B0 A1 Q of 1, right? Minus B0 A2 Q of 2, right? Is that good with everybody? Plus B0, there's a reason why I wrote it like this. See this pattern? A1 Q1, B2 A Q2 2. This is a patterns class, by the way. You'll start seeing things like light bulbs, and you'll figure out ways to make your MATLAB lives easier. So this is my current state, right? It's another current state, correct? So if I were to do my Y of n, right, it's a 1 by 1 matrix. Yeah, it's a 1 by 1 matrix, right? Because that's what the output. We want to calculate a number, right? Let me give you the answer. Q of n. What's Q of n? This right here, right? You're already given that, all right? Boom, you love givens. You love when things are given to you, right? But now you got to enable these things, all right? We want a Q1 right here, right? And we want a Q2 right there, right? But what's the gains right here? Minus B0, A1, right? For the first term, right? The second term is going to be minus B0, A2. This is 1 by 2. Is that good with everybody? We're understanding what we're going? Plus D and X of n. What's X of n in terms of like a number, not a matrix? It's just itself. It's the easiest one. Is that good with everybody? And funny enough, D is actually a gain from what I see. So we have a B0 term right there, right? This is a 1 by 1 matrix, correct? And this is also 1 by 1, so that means this has to be 1 by 1, right? B0, right? Does that make sense? And let me just write this with a big happy marker. And that's your answer. Does that make sense? Let me tell you this. We just put a lot of time into things that are already in the book. We just re-derived it to make sure you guys are on track. Does that make sense with everybody? This is already in the textbook. Notice these patterns, all right? You'll figure out there's something with what Dr. Stewart gives you. It won't click right now, but you'll see it. Everything's in terms of like something very generalized, and you can sum it down to something more simple so you can finish your assignment. Is that good? So let's see. Let's go back to the assignment. And we just did this for a direct form 2 block. Let's go back to MATLAB. EE360. Lec. This is 7. Doing problems. Direct form 2. So, let's see. I want an A block, right? And I want this to be a matrix, correct? We want this a matrix, right? So minus A1, minus A2, correct? How do I make another row? That, right? Does anyone bother if I do this? Wait. 1, 0. Is anyone bothered by that? No? Why? You know this dot, dot, dot right there? It's just continue to the next line. Actually, let me just try something. Do A1 is equal to, I don't know, 0. A2 is equal to, I don't know, whatever. Control run. Hold up. Semicolon terminates things. Is that cool? Matrix? Everyone understanding what's going on? So we want A1 and A2, right? That's set up, right? So these are things you would punch into your thing. Wrong code. Punch numbers here. Don't forget to put your semicolons, because if your code starts barking, then that's not good. Does that make sense with everybody?
Yes. It's important that I found it.
What's B? It's a 2 by 1, right? So how do I make a 2 by 1? There's this. And then if I do this, I don't know, dot, dot, dot. Hold up. 0, 0, 0. Actually, nah. I'm too lazy. There you go. That's a 2 by 1, right? Is everyone understanding? Very basics first assignment. Cool. What's C? It's going to be a 2 by 1, right? Oh, wait, no. 1 by 2, right? So that means I just got to type some stuff. Minus B, 0. Wait, hold up. Dot times, there we go. A1. Put a space there, right? giving some random space, minus B0 dot times A2. Why I do the dot times? Because I'm very, matrices scare me. So I like keeping everything scalar. You can do a normal multiplication, but if somehow you don't instantiate your numbers, stuff that you don't want happening will happen. Is that good with everybody? D. And that's just a 1 by 1, right? B0, boom, you're done. Is that cool? Everyone gonna get good grades on this assignment? What's our Q? It's a 2 by, what do you call it? It's a 2 by 1, but we also want to make it a vector. It's going to be a vector because n is our time, correct? So, okay, based on our notes, right, it's a 2 by 1, right? Q of n is 2 by 1, right? So let's just think 2 by 1, all right? Let's not think deep. So I'm going to do Q1, right? Do this, dot, dot, dot. Q2, right? Is everyone following me? 2 by 1, right? And that's just the current point. Does that make sense? All right, we're not dealing with time right now. So I'm just giving you guys a helpful hint. What's Y? I'm going to do this, capital Y. Y is just, well, it's just a self, that's it. There's nothing really. It's just Y. There's nothing really to say. It's a 1 by 1. That's what we're trying to do. It's just a number. It's just Y. That's it. Does that make sense with everybody? We're all following? So the reason why I didn't do anything, okay, we can just do that. Is anyone mad that I did it 1 by 1 as a big capital letter Y? There's nothing really to say, but it is technically a matrix. 1 by 1 is a matrix. Is that good with everybody? But we want to solve for this. For I is equal to, let's see what the homework say. We have these initial conditions. We need to make sure that your system is clean. Oh. How do I want to do this? For I is equal to, we'll just type as we go. To, I don't know, 50 numbers. And all you're going to do is Q is equal to A times, what do you call it? A times, Q of, that's the next state, because I want to solve the next state. N plus 1. There's a reason why I did this. Q of N plus B times Q X. Yeah, sure, X of N. But this is technically not N, it's I. And then this is where we actually have to start solving for stuff. And actually, worse yet, I think I did this wrong. Should be this. There's a way to do it. Is that good with everybody? And this right here is our output, right? We want to solve for our output. Y. C, Q, and D. I'm going to do some extra spaces. Does this look clean? Is that good? What does this look like from your book? You like that? That's the answer. This is what you're actually designing. What's in that middle? All right? So in your books, you're going to notice a pattern. There's a difference between how these squares are. That's what you're trying to understand. The generalized answer is this, but you're trying to design this, or you're trying to solve for that. Does that make sense for everybody? What you're trying to do for this assignment? EDA assignment. Or I don't know, it could be difficult. Let me see. Man, where is that? Let's go to our previous, not that one. UNLV, 360, F25, computer assignments, computer assignment 2. Where is that part? Look at that. Am I cheating, y'all? No? Same thing. Did anyone struggle with the last assignment? Did you know that this was the answer? You're just copying and pasting the same code. Does that make sense? Look at that. The way you design it. This is the numbers you start using. This is what the state space equations are. You have to solve for A11, A12, A21, and A22. What's A11 in terms of this? Minus A1, right? What's A12? You see how everything's correlating? That's where the transform, like direct form 2 and transpose direct form 2 work. So the answer was already given to you. All your job is to do is figure out what pieces go to which. So does that make sense with everybody? Now let's see. Let's actually start running code. So this right here is a matrix. I want that to be a matrix, but I want it to equal, it's going to equal this. I want it to equal that. Q of 1, Q of 2, because that's what I want. We're going to get this. So all these are set, because this is just a point. I'm solving for a point. If I were to instantiate some stuff, y is equal to zeros. One row, some length. N is equal to, I don't know. Oh yeah, 50. Q1 is equal to zeros, 1 of n. Q2 is equal to zeros, 1 of n. And then x is equal to zeros, 1 to n. Why did I do this? So that way we have an empty palette. We can just start designing stuff. We can start seeing what's going on. Make sure everything works. All right, n is just the length. I'm just choosing a length of 50 zeros in line. All right. But in reality, we have a delay. Do we have a delay? Not really, no. There is no delayed signals. That's pretty cool. Really? Let me see. Something's wrong. Let me see if I'm doing this assignment wrong. Something doesn't feel right. Because this right here is an input. All right, there's an output. Generate difference equation. So this one's not that bad. This one's the funny part. Because you don't have any, you're just using your current inputs. There really isn't. You're calculating the 0th point, which is just time is equal to 0, right? N is equal to 0. But in reality, I'm going to set this as, is anyone bothered by that? I'm adding a 1 because the arrays don't like it when you have a 1 or a 0 in there. So let's see. What if I did the following? I'm gonna run these. F9. Okay. So I have Q1, Q2. I wonder if you can do this. I don't know if this is possible. Let me just see. F9. Oh, it worked. So let me show you the problem that I'm trying to say. Your job as the engineer, this is a point, correct? And I want just that first point, right? So I want this first point. So if I were to do the following, Q of 1. Let me see, Q of 1. How do I get both of them? No, wait. Oh, Q of, I want all the rows of the first column. Boom. Is everyone understanding what I'm doing? Because I just want just that, right? The first point. All right, let's go to the next one. Boom. Number 2. Now you're seeing the cogs turning, right? Is this making sense how you're trying to design your code? So MATLAB isn't tough. It's just a tool to help you like get this answer done. So is this a legal way to do it? Heck yeah. Is that good right there? So this, ideally, let's see if it works. This should, like, actually the one that I was like worried about was this one. But this one, we need to make sure that this stops. I'm gonna do a safety number, 49. Hopefully it works. What should our input be? Actually, better yet, 6. 7. See if we can finish this in time. Okay, so our assignment states that, what's his name? Or do I have that piece of paper on me? Remember these coefficients from here? Right? What's A1 is going to equal, right? It's just going to equal this 2r cosine, right? 2r cosine omega naught, right? And then A2 is going to equal, what's A2 going to equal? Minus r squared, right? And what's B1 is equal to? R sine omega naught. That's what we need for our equation. Let's go back to our MATLAB. Remember that matrix? Got A1, A2, and B0. Or actually, it's not even B0, sorry. Ha 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 ha. This is where I said, if you try to like copy paste, it's gonna bite you. So, what was our B0 term? There's none. What does that mean for B0? Doesn't exist. So you know what you can do? You can either do the smart way, or you can do the lazy way. Is everyone pissed about that? Easiest assignment in the world. So I say, don't worry, y'all. What's B1? It's going to equal R dot times sine omega naught, correct? B, there's no B2. What's A1? A1 is equal to 2 dot times R dot times cosine omega naught, or omega 0, resonant frequency, right? What's A2? Minus R dot power squared. Is that good with everybody? Now let's start punching in more things. R is equal to, I'm going to put 0.99. Omega naught is equal to, what was our omega naught? Pi over 7. Pi divided by 7. This for sure, I'm doing a regular division because I know pi is a constant. So unless, okay, let's go dot divide. I'm paranoid. You never know, MATLAB can do some stuff. Let's run this. Actually, what's our input? Our input, X is the system's input, generates space equations. Oh, the input is a Dirac, a delta, Kronecker delta. What does that mean? 0 at the first point, correct? See this right here? I'm going to run this. Evaluate. Right? Cool, right? Like that? Our first point needs to be 1. So what do we got to do? Add a 1. So how do I do that? Which way should I do it? Should I do it like this? Boom. Should I do it like that? Or should I do it like this? Which way? Which way? Come on, trivial questions. It doesn't matter. It's just your design. Do you understand what's going on? What happens when I do this? F9. Double click. Double click. First number's 1, right? Boom. Next number 0. Boom, right? You like that? Does that make sense with everybody? What happens if I run this? F9. Same thing. This is easy. Bringing you confidence again. Who's ready? Run. Boom. What intonation? Oh, expecting capital X. Sure. Figure, I don't know, 6, 7. Stem, I want the time and I want the output. Label, wait, X label, time. Y label, number. The left and right sides have a different number of elements. Gotcha. Remember that thing I did with Q, right? Where I want Q, right, of all the columns of the first row, right? I forgot to do that right here. I want all the columns of whatever that is. Is that understood with everybody? Because I'm just siphoning just that first point. Is that good? I want the rows. I want all the rows. That's what the colon does. All the rows of the ith column, of the first column, the second column, third column. Cool? And then same thing right here. All, boom. What the heck? N does not exist. Why? Because I didn't. 0 to N. Boom. Doesn't run. Let's see what happened. Where did we go wrong? R is equal to 99, B is equal to 0. What was our B0? Hold up. Did I do this right? Let me see. Because I think what's happening is if I did this correctly, something's not right. I think I did a mathematical wrong. Let me show you what's going on. So when B0 is equal to 0, right? This all disappears. This all disappears. What does that mean? It's all 0. So what did I do wrong? B0A1. Did I do something wrong in here? Y of n is equal to this, correct? Which is equal to that. Oh! Caught me. I just did the first loop. What's yn equal to? B1 times this Q of 1. Caught me. B7. So I forgot our other little buddies. I did this way, right? But I forgot y can equal this way, and it can also equal this way. What's y equal to in terms of Q1? Or actually, let's. I'm gonna copy this y right here, right? This y right here, right? Let's see. Y of n is equal to Q of 1 of n, B of 1, there we go, plus Q, or B of 2, Q of 2 of n, right? Is that good with everybody? But there is no B2 term. Is that good with everybody? But I'll just keep that there. So what's truly my y of n, my vector? If I were to do the following, let me just do this. Da-da-da-dum. We have an extra q term, right? So that means it's going to be bump. Is anyone bothered if I do q1 b1 minus b0a1 and then b2 minus b0a2, and then this is my q, and then there is no input. Cool. Is anyone confused with how I did that? So, okay, I kept this term, right? Read the book. That's why I was like firing some stuff. Look at this term, B1, A1, B2, A2. And then this right here is B0, B0. You're going to start to notice a pattern, all right? Now let's reiterate this. So I messed up my matrix. This is your true answer. B1 minus B0. I'm going to do this because I'm paranoid by that. B1, B2, all right? Why did I put B2 there? Because I copied it from the book, correct? Is that understood? Or I just derived it, right? Is everyone understanding what I'm trying to do? What's B2? 0, right? There's no B2 term, correct? If you were trying to do the cool way of copying and pasting Dr. Stuber's book, what's B1? Well, it's already there. What's B0? It's already there. Now we have the full equation. Is that good? B0, let's run it, whatever. What the heck? B0 times A1, B2, B0 minus A2. So it blew up. Why did it blow up? It blew up. 0.01. Why is it blowing up? B1, R2, let me see. We're almost there. There's a sign somewhere. B0 is this. This is R sine omega naught. This is 2 times R, R squared. This right here is 0.99. Yeah, whatever. B1, B2, A1, A2. I probably messed something somewhere. 1, 0. But do you see what I mean? All you're doing is you're just solving for these equations. And then I just did something right there. But someone help me fix this out. I'll give you guys this, and that's your job. Figure out the next space equation. And then, what's his name? With your 3 programs, oh, you're already given these state spaces or state equations. Is that good? All right, that's your job. And then convolution. You're going to do also vector multiplication. That's the whole point. Linear algebra? Pretty simple. So everyone going to get good? Assignments due Monday night. Is that good with everybody?
Yeah, amazing actually. Instead of the day.
Yeah, because I'd rather start the next assignment on Wednesday and not the next week after that. All right? Is that good with everybody? All right. Have a good day, everyone.